And every time we have a class, you can remind me to record the session so that you will be reviewing them at the end of the session. So we talked about inferential analysis, the procedures that you need to follow, and we said the first one is you have to be clear about the test statistics and what will guide you in identifying the correct test statistic is you look at the structure of your data. So we said if you're comparing or checking the relationship between categorical variables, then I think this time I'll clarify, your categorical variable should have two groupings. So you will do test of association. Said if your variables are continuous, then Pearson correlation with the test statistics. And I think today I will start with when one of your variable is continuous and another one is categorical. So for categorical and categorical, we say chi-square. Continuous and continuous, we talk about correlation. And then today now, I'm starting with a continuous variable and a categorical variable. So I will still use the employee data. And for my case, I have it on my desktop. So you should also be having the same. So first, let's follow the same procedure. So we said you look at the structure of your data and then you decide on the test statistic. So we have identified that the test statistic that we're about to do is independent sample t-test. And with independent sample t-test is basically you're comparing means. And let's go to step number 2, which we said is what you need to formulate your hypothesis. So what is the hypothesis for an independent sample t-test? So there's a general hypothesis, and then there is a specific one, now depending with the type of data or the variable that you're working with. And in general, you will say there is no significant mean difference between or across the factors. There is no significant mean difference across the factors. And then alternative hypothesis will be there is a significant mean difference now across the factors. So what are the factors? So the factors will be now the grouping variables, or the categorical one. And then now where you're going to get the mean is now comparison from the continuous one. So let's have some variable based on now the data set that you are using. And then of course, for those who have reviewed assignment 1 and 2, you realize there's a lot of questions on independent sample t-test. I think we'll review that towards the end of the class. So in this case, I want a continuous variable. So I will use salary. And then let's use gender. So we're trying to say here, is there a significant mean difference in earnings between males and females? So of course, we can tell on the descriptive analysis that there were, I think the average income for a male was around $44,000, and for females was around $21,000. So by descriptive analysis, I cannot infer, that's why you call it descriptive. You cannot tell much. You don't have any evidence to go and maybe make noise and say, hey, males are earning more than female. No, that is just descriptive. But until you do an inferential process like what we're doing right now is when you can say, oh, okay, I have evidence to either support or maybe fail to support a certain claim. So in this case, the null hypothesis with this specific data, I would say, is there is no significant mean difference in earnings between males and females. And then the alternative hypothesis will say now there is a significant mean difference in salary, or you can say in earnings, as long as you're communicating between males and females. So step number 3, we talk about confidence level, and we said if you're in the social science field, you will do your study at 95% confidence level, which means your error margin is at 5%, and that is where you'll get your alpha value. So about the 5%, you get 0.05. Now, step number 4, we need to make a decision. Are we rejecting or we fail to reject? And now we need the two values, P and alpha, and we know alpha you get from the confidence level, and then P you will get it now from the results that you're going to get. So how do we do that? If you go to analyze, you compare means, there's a lot of options. Of course, if we find time in class, we might talk about other ways of comparing means, but I'm just using the most common one, which is the independent sample t-test. And the test variable is now the continuous one, which is current salary. And then we'll use gender as the grouping variable. Sometimes we call them the factors. And then I have to identify the values based, the groupings based on the values. And we talked about this. So we said the software doesn't know what is male and female. That's why we had to do recoding in the first place. So if you go to defining groupings, you now assign the values on how your groupings are coded. Let's say 1, for that is for I think male, and then 2 for female. Continuous, will paste so that I get my syntax. And then execute that. The first table, majorly descriptive. So we can tell on the sample population we have 258 males. Of course, I don't have to talk about all this. We discussed about the $41,000 on average. That is the salary for males, then $26,000 for females. The standard deviation on the same. Of course, by now you should know how to interpret standard deviation. But just note the closer the standard deviation towards the mean, the higher the rate of stability. That is the most important one. Now figure out your recommendation towards that. I think you can proceed and even discuss about standard error of the mean, but I always prefer you be deliberate in terms of the mean and standard deviation, as long as you're giving out insights. Now let's go to the main area, which is on equal variance assumed, which is basically we're just doing t-tests for equality of means. And what we're looking for here is the p-value, and I'll get the p-value from significance at two tails. So of course this one is a two tail because we are comparing two things, or we're doing what you call mean. We are comparing mean, whereby we can say the mean difference is equal to 0, or the mean difference is not equal to 0. I think that is the hypothesis that we're actually doing here. And because we're using equality sign, that's why we're doing two-tail. So I have 0.00, which is less than 0.05. And we said the rule of thumb is when your p-value is less than the alpha value, you reject the null hypothesis. So what is our null hypothesis? We said there is no significant mean difference between males and females. That means you're saying the mean difference is the same as 0. So we are rejecting that. And if you're rejecting the null hypothesis, then it means we're saying the mean difference between these two factors is not the same as 0. That means that difference. We can tell from here it's 50, which is basically $44,000 minus $26,000. So that is the difference which we are telling that it is significant. Education level, but we said with correlation analysis, you will only tell the cause, but causation okay can just mute your mic. Charles, you can confirm now if you're seeing anything. You should be seeing.
Right, right. It's now visible.
So I was talking about correlation, which I just said. Correlation will just tell you how those two variables are related, but doesn't tell you on effect. That's why when you were interpreting your correlation coefficient, you said what? As one variable was increasing, the other one was also increasing or decreasing. But we didn't say as one variable was increasing, it caused the other one to behave the same, the way it was behaving. But now the question is, who will answer that question? So that is where you will introduce now regression analysis, whereby with the beta coefficient, or when you come up with now a model, you can now use that model to do some sort of estimation, which is now what we call analytics. So most of the things we have been doing was analysis. We are trying to understand the past. But now with regression, we are trying to tell, or we are trying to estimate, or we are trying to predict. And you can only do prediction using models. And I think right now we are at a space whereby now we are talking about large language models. I think that is the advanced level of where you can go. And with large language models, I think GPT is one of them. So you guys are basically in a space whereby you can train your own models at some point. So as long as you can come up with features, so you should be having your 1 trillion feature, maybe, or 170 something billion features. So those are just now the data that you have. So anyway, so I'm going to talk about the first, or so there's a file I shared on regression analysis. So I hope you have had a chance to read through, because I'm not so good with working with the presentation. So you'll just find your own time to familiarize with the theoretical part of it. But for those who are doing maybe economics, you have covered a lot on maybe econometrics. So for those who have not maybe done a lot on these kind of things, it's easy. You can just review these notes and then you'll be good to go. So when you talk about linear regression, there are several instances that you can use that, but in this case, I would just want to know what is the effect, or to what extent does someone's salary will respond after an adjustment to the education. And other cases, you can say, for instance, if you want to explain students' grade, and of course you'll use the number of hours that they have put some energy on a certain course. So it's the same case here. I will know who has invested their time on their performance based on how you send your work to me. So that is one way of using regression. You can use educational income, I think is the case we're using now. Then, of course, a common one is on real estate. The number of bedrooms will always determine the price of a house, unless otherwise. And then you can also talk about stocks and recession. I think I tend to believe right now we are facing some sort of recession. So you should be playing around with the stock prices. And of course, that's how you make money. So play around with those stock, and now understand what happens during recessions. So like I said, in this class, I'll just be using the example of salary and education level. So let's talk about a model. And again, there are several regression analysis, but here I'll just be talking about linear or a linear model. And with linear model, this is where we introduce the concept of ordinary least squared or OLS. So an OLS model is a model that borrows a lot from a linear, like we say, yes, we borrow from a linear function. Okay, and a linear function, now that is not econometrics, that is maths. So of course, we're using maths to model our economic concept or whatever concept you're having. Of course, I'm a bit biased, but I'm not saying that whatever I'm saying is the situation for everyone. But now when you talk about a linear model, this is where you're saying I'm just fitting a line that should cut across where we have as many points as possible. And of course, those points are now the distribution that you have. And by fitting that line, that's why you introduce the concept of the blue concept, the best linear unbiased estimator. The thing that is a concept by Markov. So for econometrics, you can just go and read on the assumptions of that guy. So when you say best linear unbiased, we're borrowing from a linear function, which is y is equals to mx plus c. That's how you draw a line. And if you convert that into, so this is what I'm talking about here. So when you want to draw a line here, you will use that formula, and now we are borrowing from that to fit in the econometric model. So what are the elements of an econometric model? So by default, we have y is equals to beta naught plus beta 1 x1. So y will be your dependent variable. So there are a lot of names that you can use for that. Sometimes we call them dependent, independent, outcome, and features. There are a lot of ways you can identify that. I think exogenous and endogenous is also a common way by social scientists. So beta naught is the constant term. So in a linear function, we use the c or the constant. Of course, these are just ways of identifying your elements. So beta, what is beta naught? We're saying, maybe I use the example of autonomous consumption, whereby if you have a consumption function, you say what you consume is equal to the autonomous consumption plus your marginal propensity to consume. We can say that fraction of your income that you're dedicating it now to consumption. But now let's talk about autonomous consumption. What is autonomous consumption? Now we say this is now what you consume even when your income is zero. So that is the best way I can explain the beta naught situation. But let's go to now the most important one, because as I give you a glimpse on machine learning and large language models, you realize that sometimes we will have to not pay so much attention on the autonomous one, even though it's part of the function. So when you're doing scaling and validation, anyway, so beta 1 means what? That changes or the variation that will happen due to adjustment in your feature or the independent variable. So while holding all the other factors constant, what does this mean? That fraction of your dependent variable that is changing as a result of changes in your independent variable. So how do we interpret this one? We'll now say while all the other factors are held constant, a unit change in x1, your y variable will respond by beta 1. Of course, you guys have been calculating this in class, so we'll be doing that in regression, whereby the software will just provide for us the figure. So how to interpret it is the big deal. Now, before we even talk about interpretation of those beta coefficients, there are three types of tests that you have to do. So one, you'll have to talk about R squared. Of course, I gave you advice to go and read about it. So I hope we're in the same page on what I'm talking about. Also, like I said, if you read this file, you should be comfortable. So the percentage change in your y that can be explained by the x's is what we refer as the coefficient of determination. Okay. And of course, when you say a coefficient, so that means it's some figure that we'll have to convert them to percentage. And if you have if you're dealing with an econometric model, we say now your R squared should be not less than 25%. So if you get a model that has less than 25%, we say like your model is too weak for prediction. So you need to work on your independent variable. So to fix that, you add or you find other independent variable that affects your dependent variable. You say what? The R squared is your overall change in your y as a result of the x's. So if your x's are not enough, then you need to go and find more. I think most people fall for that trap. That's why they spend a lot of time in academics. Because if you don't, by the time you're figuring out your objectives up there, you should know how your data looks like before you even start a project. So that just in case your data is not making sense, you don't have to waste your time reviewing all those literatures and conceptual framework. And also maybe coming up with some methodology. So the second test is on so what does that mean actually? Let me just emphasize on 0.25 for instance as an R squared. So we say you convert that to a percentage. So you say 25% of changes in your y can be attributed to your x. So if you have variables like now salary and education, so you can say maybe 25% of changes in someone's salary can be explained by the education level. The second one is on F-test, which you said F-test is also referred as ANOVA. And ANOVA here we're just trying to look at the goodness of it. Is your model fit for prediction or not? So here is basically by combining both your y and your x's. Are they significant? So we said on significance, there was only one thing that would determine that, which is the behavior of your p-value and your alpha value. So if you're rejecting your null hypothesis, then it means your findings are significant. So during the F test, we will just compare the p-value and alpha value. The last one is t-test. And t-test here, we will talk about significance of each independent variable. So first, I've already mentioned about significance and how to identify significance. So by using t-test, we will now go one by one. But that is if you're having a multiple, maybe if you're dealing with a multiple linear regression, that means you're having more than one independent variable. If you're only having one independent variable, then it means your p-value for f-test will also be the same for t-test. So it will not make sense. So basically, whatever you'll find in your f-test will be the same as what you'll have in your t-test. I think we can now do the practical part of it. So it's your job to go and read this part or this document. So to run regression, I'll just go to analyze, then regression, linear. So my dependent variable is salary. So I want to know how salary will respond after changes in my education level. So you can introduce others type of results output, like for instance, now I hope so hopefully the what you call diagnostic test, the pre and post estimation. So the pre, which basically means the diagnostic test that you do before actually the estimation, and then there is now the post, which are now those diagnostic tests that you do after the estimation. And why is that important? Because we don't want to interpret the beta coefficient which are inflated. And what are these diagnostic tests? So one, we have the normality test. Two, we have the multicollinearity test. Three, we have autocorrelation. Then four, we have heteroskedasticity. So if you want those results to be provided for, so for those who are doing pure economics, sometimes you're not required to provide information on things like covariance. I think also for diagnostic test, but you can select now them here. Like partial correlation, you can also get the results here. The Binwasson, I think that is for heteroskedasticity, and this you covered in econometrics. So as I said, for those who are doing economics and statistics, you guys have covered this. That's why in your projects you are required to introduce the diagnostic test. So I'll click continue, and then what else? Let me introduce on stepwise. So there is, you can either do this stepwise method, which again is useful when you are having multiple linear regression, because you have more than one independent variable. And what it does is it will provide for you details based on the order of significance your independent variable. I think that's why we referred to it as stepwise. So some sort of balancing. So of course I only have, let me introduce previous experience so that I have multiple linear regression as opposed to just having education. But of course I'm sure there's a video for this class, like this regression. And also maybe at your own free time, just attempt first with the only one independent variable, and then you can also do now with all of them. But now I want to use stepwise method, but maybe on your side you can just do the normal one. I will paste window syntax, and if I execute my code, so this one is just indication of how the variables were entered. And let me know if you're not seeing my screen. I hope you guys are seeing my screen. Okay, so they're saying what the first model is on education. That means education was entered as the independent variable, and then the second model is now with the previous experience. On model summary, this is where you get the coefficient of determination, whereby I can, now again, I'm getting results based on the model. So what is the coefficient of determination when only education was entered? So we can say education alone can explain 43% of someone's salary, while the combination of both education and previous experience, we can now explain 44% of changes in someone's salary. So by this alone, you can tell between the two which one is a big deal, like who contributes a lot to the changes in salary. Like, do you want to go for internship, or you want to go back to school and do your masters? So if you're looking for money, I think by going back to school will help a lot in making you more money. That's what this information is saying. So let's go to ANOVA, which is, we said, is just basically talking about goodness of fit, or is your model fit for prediction. So of course, in having both models, so the first one, of course I have explained this to emphasize this. The first model is when you're having education alone. So with education alone in the model, I'm still having a significance of 0.00. So we're saying education is the model with education alone, it is significant. Of course, I'm rejecting the null hypothesis, which is what the model is not significant. The alternative, the model is significant. So when I'm having both of them, that means I have both education and previous experience. And again, you can also tell from your degrees of freedom. So here I'm having degrees of freedom at 2, and here I'm having degree of freedom at 1. So if you do the n minus k, I think you should be able to note that the second model has 2 independent variables. Let's talk about the coefficients now. Of course, with the first model, you can see with the constant term. So this one is a simple linear, but I'll focus with the education level. So we'd say what? First, let's check if education is a significant predictor. So yes, 0.00 is less than 0.05, which means education is a significant predictor of salary. But let me focus more on the second model. And now I have 0.00 and 0.038. So I can tell here that the closer the p-value towards the alpha value, the weaker the predictor. The closer the p-value towards the alpha value, the weaker the predictor. So the more your probability value moves towards the alpha value. So the alpha value is 0.05. And previous experience has 0.03, so it's moving towards 0.05, and that's why it is a weaker predictor of someone's salary compared to education, which had 0.00, which is less than 0.05. So while holding all the other factors constant, a unit change in education level, someone's salary will change by $4,000. Then for previous experience, again, while all the other factors are held constant, changes in previous experience will result to a change of $12 in your salary. I'm not going to explain in terms of course, I think we talk about correlation matrix or how to interpret correlation coefficient. But for someone who wants to understand more about diagnostic tests and how to now, so there's a class on advanced research methodology. So for those who want now, for those who are maybe in master's class, I'm not so sure about my audience, but you can learn on how to learn all that. But I think I'll stop there. And now by this time you should be comfortable to do both assignment 1 and 2. And tomorrow I will be handling assignment 3, so I will just teach on assignment 3. I have shared the same in the class or subgroup, so for those who will be able to do it before class tomorrow, then that's a good thing. But I would want us to talk about assignment 3 and how you would have solved that. But on your side, make sure you send to me your assignment 1 and 2, all of them. Any question or concern before I leave? Okay, so if you're good, then let's meet tomorrow.